Hello everyone and welcome to another episode of Let's Code Duke Nukem, where we aim to recreate the original EGA action platformer, released in 1991. Last episode we managed to introduce a simple way to detect collision between the player and the level when moving around using the arrow keys. So this episode we will replace the up and down keys with a jump button and gravity tugging on our player. We want our jump to feel as authentic as possible, as close to the original game as we can get it. So what I did is I made a screen recording of a jump in the original game, and I slowed it way down to analyze each frame individually. I counted the total amount of frames, the amount of pixels that Duke would go up and down for each frame. So it seemed that Duke's initial jump strength is 13 pixels going up, decreasing by 2 pixels for the next couple of frames. Then there's a hang time of 3 frames where Duke just floats in the air. And finally Duke will fall down, which has a fixed speed of 8 pixels per frame. So with all these frame counts and pixel values, we can start implementing jumping and falling. All right, so let's start by adding the key to our key handler, the jump key. So let's add a boolean that keeps track of the jump key was pressed. And let's assign the control button for the jump key. Is jump. And then in our handle input, we can say we'll keep the acceleration function for the up, down, left, right keys for now, so we can still fly around in the level. So let's just add the jump key as a separate key, which tells Duke to jump. Or try to jump at least, because jump is of course not always possible. All right, so here we have the jump. So we said that we had a couple of frames of where the velocity changes from 13 to 9 to 5 to 3, and then 3 times a 0 change. So this tells me that we cannot just assign the velocity y to minus 13 and just increment it by 2 each update, because we have these 3 frames of hang time here. So I think I'll just introduce a variable that says like jump frames left, and then we'll assign it to 8. And then we'll add that one to the class here, create a field, jump frames left. So that is minus 8. So then we can jump. So let's make a private function, private boolean can jump. Return jump frames left is 0. I think this function can jump should actually check whether or not Duke is standing on the floor or walking around, like if he's on the ground at least. But we do not have that as of yet. So at this point, the best thing we can do is check if the jump is done. So check if we can jump again. Okay, so if we can jump, then set the timer to 8 frames and then set the velocity to minus 13 to go up. So that's cool. So then what we need to do is we need to go to our update function and here process the logic of our jump. So if we are jumping, jump frames left, if that's larger than 0, that means we're still jumping. Then let's decrement the frames left, going down to 0. Here we want to increment the velocity by 2, because remember we're going from minus 13, minus 11, minus 9, etc. However, for the last 3 frames of hang time, we need to check if the jump frames left are larger than 3, then we can do the regular gravity. Otherwise, we need to do velocity y equals 0. Okay, so I think this is looking fine. The only thing we need to do now is in this move vertically method, the velocity y is set to 0 every time to basically say like, hey, we've done the movement, so reset the velocity. But now we need to preserve the velocity across the frames because we're jumping up and we're calculating new velocity. So I think we'll just reset it to 0 if we're doing anything else but jumping. And this is where the regular gravity will be implemented in just a second. Okay, so let's go ahead and fly to a recognizable spot. Let's hit the control key. All right, and Duke moves up. But Duke doesn't go down just yet, but we'll fix that. But this is looking pretty okay. We can jump up, and it feels pretty natural to me. All right, so now we can go up. So now we need to go down. And like I said, the gravity in Duke Nukem is 8 pixels per frame. There is no acceleration or deacceleration. So I think what we can do is, because we've already moved here and our collision detection takes in account the new position, I think all we need to do here is in this update function say like, okay, if we are not jumping, then let's assume gravity is pulling downward. So set the velocity to 8. And yeah, let's run it and see if this works. Now this will cause us to fall down immediately here in the level. So we need to press right as soon as we can. But let's jump. And Duke is jumping up and down. Yeah, and I think this looks pretty good. Pretty happy with that. Okay, let's see what happens if we bump our head. Okay, and there you saw some weird stuff going on. Like here we're floating across the floor. And we are floating across the ceiling as well while we're jumping. So that tells me a few things. That means that we need to set our jump frames to 0 immediately when we bump our head. Plus, more importantly, our collision detection algorithm is a bit too coarse-grained. It just checks the new position, but if the new position is already a couple of pixels away from the edge of the cell that is still available to Duke, it will not update its Duke position because the new position is already in an occupied cell, but there's still room to move towards it. So there are multiple ways of fixing this collision response. We can calculate intersections and then adjust our position based on that. But I think the most straightforward one is to just check, instead of just our destination where we want to go, we also check every position in between of that of Duke and the destination. So this will result in a few more collision checks, but I think it is the right way to go. So let's adjust our vertically moving collision detection algorithm. So we'll keep track if we collided or not. And we need to know which direction we're going, up or down. So we can get the sign from our velocity. So this is going to be either -1, 0, or 1. And we need to keep a counter. And then we can say like, okay, as long as we haven't collided yet and our counter is less than the absolute value of the velocity. So this will just say like, hey, I'm going to iterate, let's say velocity is 4, then this loop will run 4 times or until collision has occurred. Let's increment I. Okay, then we can go with our new position. The new position is going to be 1 pixel away. So we can just increment our I position with the sign. So either going up if the sign is -1 or going down if the sign is +1. So our new position is going to be 1 pixel either up or down. So then we can check for collision. Collision is, I'll just copy over this here. If we collide with our new position, if collision, then we have collided, then that means that we need to immediately set jump frames left to 0. If we have not collided, then that means we can update our Y with the new position. And I think that is it. So let's see if this is now a bit more precise collision detection. So let's move back to where we bumped our head earlier. All right, and now we can see that Duke immediately falls down when bumping his head. And there are no weird floating shenanigans going around. So that's looking pretty nice. Okay, well, this went a bit smoother than I thought. I thought jumping and gravity would take a lot of time to implement, but we're done in 10 minutes, so that's nice. Let's see if we can make this into its own function. Let's extract this into, oh, that's the wrong button. Cancel. We have move horizontally, move vertically. Let's make a private void. I don't know, apply gravity or something. And then obviously we need to call it here, apply the gravity. Okay, so now that we have a little bit of time left, we can make our can jump function a little bit better. We will probably introduce a variable that says if Duke is on the ground or not. Private Boolean, I don't know, touchdown or something. And then in our move vertically method, we can say that if we collided, reset the jump, and then if our velocity y is larger than 0 or equal then, no, that's not going to happen. So if our velocity y is larger than 0, then this means that we were going down and that we collided, so that probably means that we are on the floor. So then we can say here touchdown equals true. So now can jump equals touchdown. So touchdown has to be true in order for us to be able to jump. So we need to do what we need to do here in our apply gravity method. I think what we'll do is, let's see, we need to set the touchdown to back to false when we're jumping. Now the easiest way to do that is of course to just do that here. Touchdown is false. Okay, let's see if this works. So now I'm hitting the control button and it won't jump until it is back on the floor. All right, so let's take these last few minutes to do something about Duke's starting location, because starting in the top left all the time is not how the original game works. If we go to the Duke 1 level format webpage, we can see that there's a player start location tile ID, which is this one here, tile 3032. So what we'll do is we'll go to the resource loader and keep track of the player start location, and then adjust Duke's position accordingly when loading up the level. So let's see here. So let's first assign this to a tile ID variable, and then let's check if the tile ID that we found is tile 3032, which is the player starting location. So the player start location is not a real tile that the game can display, so we probably also need to override the tile ID here with the tile to the left, I-1. Okay, so this needs to be an integer, fine. So we'll override it to the tile to the left so that there is something proper to display. Otherwise, you know, if you spawn in an area with like nice background tiles, it will leave a gap. So this will fill up that gap with the tile to the left. And here we need to keep track of the actual start location. So let's just start location. Let's save the address. start location is I, right? Because I is the location in the level that we're iterating through here. So here we've kept track of it. Let's assign it to 0. That should a level not have a player start location, we'll just start at the top left. And then what we'll do is we'll just pass in the start location as part of a parameter of the level. Start location. And then here, start location. And then assign it here. And then what we want to do is we want to translate that to a player Y and a player X position. So let's say public int get player start X. Now this start location integer is an address because we have a single dimension array. So what we're doing here is we're calculating the address based on the row and the column. So here we need to calculate it back from an address to a row and a column. So let's say return player start address, start location. So we need to divide this by the width. And then we have the grid cell column that we are in. So we need to multiply that by the tile size so that we get the actual world X coordinate. And then we need to do this with a %, and the Y needs to be done with a divide. Okay, so this will give us the X and Y position of Duke's starting location. Now the resource loader will recognize the start position, so all we have to do now is update Duke's X and Y coordinate when loading up the level. So let's go to the game state. So here we're instantiating Duke, and here we're setting the level. So let's just give Duke a move to method, move to int x, int y, this x, x, this y, y. And then in the game state, let's say this is okay. Move to level dot get player x, level get player y. Okay, so now let's run the game and see where it leaves us. And now we can see that we're falling at the correct start position. So that will make our testing work a bit easier as well. That we don't have to start at the top left and then go all the way down to the right to get to recognizable territory. All right, so I think that'll conclude that for this episode. We've come a long way. We've implemented jumping. We've implemented gravity. So for next episode, I think it's time to actually start drawing Duke. Because right now we're looking at placeholder graphics and we have the sprites, so let's use them. So I hope you'll join me for that one. If you have any questions, then feel free to let me know in the comments. If you're liking the series so far, then please consider dropping a like. And I'll see you guys next episode. Bye-bye.